everyone.
Hello, hello, hello. It's so great to be back on stage. This is years.
It's a little weird.
It's years, but it's nice to see everyone here. It's nice that everyone is watching us online. We have a bunch of stuff to show you today. We're talking about stuff from the era of .NET 6 and .NET 7, which is not out yet. Hopefully you've all been playing with .NET 7 as we've been building it this year. RC2 came out last week? Yesterday? Yeah. Yesterday. Yep. And so we've got a bunch of stuff to show you. I'm going to switch over. We don't have any slides because I was told no slides, so I didn't do any slides. But we have a bunch of stuff to show you. I'm going to show you some stuff first, and then Farrell's going to take over, and then we're going to go a little bit of back and forward. If you're online, please ask questions. We can see them, and if there are things that we can answer while we're going, we'll do our best to do so. We'll also have some question time at the end for folks in the room and for folks online as well. So, with no further ado, what's that?
Damien, David, do we...
Oh, who am I? And who are you? Yeah.
David.
Fowler.
You're my PM.
And I... So I'm going to write PM code, and then Fowler is going to fix it because he's an actual engineer.
I will judge you by watching you on screen very closely.
And you will make me feel nervous. Okay.
Logging. So everyone knows that logging has been part of .NET Core since inception, right? We have an iLogger, there's event source, there's all kinds of ways to log events and systems in .NET. We added in .NET 6 a thing called request logging. So in some applications, people want to log the entire request and response. They want to log the headers, their values, the bodies, if they want to, for auditing and whatnot. Looking around, what I saw even internally at Microsoft and in the open source and in big companies, people logging these things would write very code that was not efficient. So let me show you an example of what that could look like today. You're in full screen mode.
Alt-Shift, yep.
This is Damien's laptop.
Alt-Shift-Enter?
Alt-Shift-Enter. There we go. Back to the screen. All right, so here's an application. And here's a big warning, don't do this. If you have this, don't feel guilty. This is what everyone would do by default. All right, so I have a piece of code in the application that runs every request, and it buffers the entire request body, right? Because you need to actually replay the request after having logged that data.
So hang on, the request is coming in. I want to read the data from the request so I can log it, but then I have to rewind the request effectively so that my app can actually use that data.
Right, so you're logging the headers first, so you create a string builder as you would. You log every header here, and then you log it to the response via whatever you want to log to. And then we read the entire request body using a stream reader, which pulls the entire thing into memory as a giant string, and then logs that information to the system as well. And then we reset the logs.
Right? So that's fine.
Memory is super cheap. Actually, it really is.
Okay.
Storage is cheap. So we reset the position of the body to make sure that other code that runs in the pipeline can read the body again. So it's happening twice, right, per request. Not great. And then for the response, it's interesting. The pattern here is you need to set a sink or a stream as the response body so that other code that runs can write into the body. You catch all the data, and then you log it as well.
So you replace the response body stream with your own stream.
Exactly. So the typical pattern here in ASP.NET Core is you store the old body, right, the current body, and then you set a new body, which is the one to capture all the content. You write into it. So you call next, that runs the pipeline that does routes and MVC and stuff. That unwinds. By that time, you've written the entire response body into memory as a giant array, because why not? And then you re-encode that byte array into a string that's UTF-8, hopefully, and then you log it to the system as well. This code makes me anxious. And then to finish it off, we get the same buffer that we buffered for the response, and then we write that back to the actual output stream, right? So this is the typical dance that you see in anyone trying to write this code in production, right? It's not, there are things wrong with it. I don't want to judge anyone if you have this code.
It's very difficult to get this right. To get this written in a way that is efficient, correct, and doesn't impact the system.
No one said secure. So a couple of issues, right? So performance is one thing. So I'm reading the entire body into memory, literally as one string. So stream reader, this is super convenient. You create a stream reader, you read the entire thing as a string, and you log it. That's super convenient, and you get it as a single entry in logs.
Right.
But that might have issues if the client sends a giant message. So if you can control the endpoint, if you know what size payloads will come to that endpoint, you may want to have the size be a limit that isn't huge, so you can actually prevent that from affecting performance of your application. So this is typical. It's not the worst thing in the world. So
but you've seen code like this.
Everywhere.
In customers?
Everywhere.
Okay.
After seeing this pattern a couple times, we kind of went, maybe we should build a thing that is more efficient here, that does the code that nobody wants to write because that's really, it's more difficult to write that code.
Okay.
So,
Blow me away. How easy is it now?
haha, so there's a new feature in this region, hidden region, that no one can see. I'll expose it. And there are two new features. Let's go through this one first. HTTP logging is a new feature in ASP.NET Core in .NET 6. And it basically does this for you. And it does two things that are really interesting. You can specify what things you want to log. So there's an enum here. I can say I want headers, I want the body, I want the request headers, response headers, properties, body.
That's flags, so I can just
and it's flagged enums.
Okay.
So I can combine these to say I want this, I don't want that. You can say I want the path, the request. You can get as small as you want.
Or I can just say all. Just
or I
give
can
me
say all. Okay. I'm lazy. So I want to log everything. But the other part of this that's interesting is in this default case, I guess I should show this running first to make sure it actually does run. Let me change the startup project to be request logging. And I'll run this, and hopefully it works. Starts minimized. And there it is. Awesome. Woo, works great.
So that's the browser request that was sent.
This is the
and then the outgoing as well.
Yep.
Okay.
So you get the request data and the response data. Not very attractive to look at, though. So now let's use the built-in logging feature in ASP.NET Core. I will minimize this. Don't do this. Okay. And then middleware part, we'll do our hidden region. Use HTTP logging. This is the middleware, and this is the way to configure it. So I'll tell it, log all the things. I'll run this again, and it should show me data.
Oh.
So this is an example of a log from the HTTP logging middleware. And you can see it does a couple of interesting things. It logs the request path, the protocol, all the things as key value pairs, all the headers. But it has this thing called redacted. So we have a default notion of which headers are safe and which ones are unsafe by default. So you can, and this is also configurable via options. But the other thing I didn't mention was security. Do you want to log auth tokens? Do you want to log things that may be insecure that come in the request body? So that's one of the other things that comes up that I think that isn't considered when people write the simple code. How do you handle redacting things that may be sensitive?
What about privacy concerns and things like that?
Privacy concerns, yeah, exactly. Do you want to get sued and get hacked by GDPR or guidance and stuff? So
because these logs could go into some other system that maybe doesn't have the protections of your production database and those type of things, right? Okay.
So there's a notion of trying to redact headers, and the way that works is by default we have a known set of headers that are safe and ones that are unsafe. So for example, the auth header, the auth token, that's not there by default.
Right.
And you can add your own. So for example,
the authorization header.
Yeah.
Yep.
You could be like content lengths are super scary. So you can do this. I don't know why, but maybe it is.
Okay.
And adding to this list says print the key, but the value isn't there anymore.
Oh, got it. Okay.
The other feature it has is request body limit. So by default, we buffer the request on your behalf, and as you read the body, we actually wrote all the crazy code to manage buffering efficiently, and as you read the stream, it will buffer to a background, a pool buffer, and it will go to this as it needs to, etc.
So this isn't going to destroy
It does all the hard code for you, right? Yeah. It does all the code
that memory.
Correct.
Okay.
It does the code in the right way to make it such that it's efficient.
Okay.
And the other knob is if you just want to log the first couple of bytes from the request, not the entire thing, you can limit the body. So let me show you what that looks like in Postman. Ooh. This is a brand new Postman. Look at that. No request.
I re-imaged my laptop yesterday. So everything is shiny and new.
I'm going to send a raw JSON request. It should be JSON to this endpoint. First, let me make sure this works. And then, my age is, young. Whoa.
Your personal trainer is wonderful. I should get
Young at heart.
well.
Does that work? Did it blow up? Did it work? So I have what I have here. Post to this URL. Oh, I did HTTPS. Is that why it's complaining at me? Yeah. Ha! Disable it. And you never care about.
You're doing a get right now, and yes, it's yes.
That's
two things. It was two things.
Two things. All right.
Well done.
And it's correct. So let's now look at the output of this in the browser, and you can see it logged the, wait, was it running? It had to be running. There it is, the body that came in, the request body, and the response body, right? Super simple.
Nice.
Now, let's do something crazy and increase this to a giant. I have this big JSON payload that I just...
How big?
28 kilobytes.
Okay, that's nearly, oh, okay, that is big.
Bigger than the large.
I mean, it's not. I hear, like, people send megabytes.
5
JSON.
megs?
Yeah.
Yeah, I know, you're right.
Multi-megabyte. Probably bigger.
This is
Someone in the
biggish.
audience is sitting there going,
That's
a
tiny.
lot bigger than that.
So it logs the whole thing. This is what you want. So you're in your logs, and you're scanning your logs, and you're seeing these giant payloads.
But if I wanted to redact something in the body, is that possible?
Huh?
That's a little hard, honestly.
Much harder, because that requires understanding what the body is and,
Right.
and scanning it.
Effectively
and-
parsing it.
so
and
that is still like
that's a
not-
custom thing if
yeah.
you wanted to be able to do that.
Good
Okay.
luck.
Fair enough. Fair enough. That makes sense.
No,
But this is much better. Like having this
Much
ability
better.
in the box, I imagine.
and it's efficient by default.
Okay.
So
Excellent.
I'm going to log the first 1K of buffer. That rebooted. That should just work. Beautiful. Wait. Oh, that's the wrong one. Which app am I at? Rate limiting? This one. This one? Nope.
No, that one's ended.
If only I knew it. Oh, there we go.
There we go.
All right, is that it? Let's see this works this time. Post, and it should have truncated the. Oh,
Yes.
that's the response body. It did. So the request body is truncated. This is the first, whatever, 1K of the JSON payload. Not useful, but if you did have something that
It might be
wasn't-
enough to
that's
debug
okay
or-
truncated,
right.
you may want to have something that isn't the entire payload, so you can actually debug what's going on.
Okay, so this looks like super feature rich and super impressive given how difficult the other things sound to do. How hard was this to build for us, like quickly? Like, we have experience doing some
time?
things in MVC and
Yeah.
stuff. Like, we do efficient things to ensure that if large bodies or large
Yeah.
responses, we try not to, but that has a lot of stuff in it. I mean, that's kind of impressive.
It was tough. I think one of the hardest parts was figuring out redaction and security.
Okay,
So having a model where you want to like opt into things and like opt out of things, that was kind of a new paradigm in the platform we have to kind of build in.
okay.
We don't have a concept of redaction from logs in .NET, so that was a thing to build in here.
Cool.
I guess the one other thing I would show is we have this thing called W3C logging. If you've ever used IIS, there are these logs that it spits out on disk by default. So we have this other piece of component that runs in the pipeline that lets you get those logs back. So if you had tools that script those logs and figured out that give you stats on those logs,
Right,
etc., you can now use that same tooling on .NET.
So this is like
7.
web server level logging as
web
opposed to
server level logs.
application level logging.
Right.
Right.
So I turn on that component, and then I add it to the pipeline. I say I want to log all the fields. This also isn't the same pattern where it has a flags enum, so you can turn on individual fields that you want to see. And then I get a logs folder by default in the application.
Oh, it goes in the fold?
You
Okay.
can change it. You can configure where it goes and when it buffers and when it rolls over to the next
Right.
file.
Okay.
And it shows you the typical IIS style logs where it has a table of fields and the date, time, IP address, name.
And because this log format has been around for a long time due to Windows and
100
IIS, there are
years.
lots of tools that know how to scrape this.
I'm not sure it's IIS specific, but
I don't think it is,
all
actually.
the tools,
Yeah.
Logman and stuff, can read this and kind of process it and turn it
Okay.
to something
And
else.
that was .NET 6 as well?
Yep.
Okay.
Yep.
Awesome.
Awesome.
Show you why perhaps that wasn't actually what you wanted and what we've done in .NET 7, just coming, to make this a little bit better. So I have an application here. If I run this one, it renders me a little monster. And this monster comes from the Gravatar service. And so if I hit F5 over and over again, I get a new one. Okay, new monster every single time. And there's if I zoom in, you can see that there's a timestamp there to tell me when that was rendered. Okay, fairly straightforward. So if I want to go ahead and add some caching to this, so rather than getting a new image every time, there's some type of caching, well, there's a few things I can do. Let me go down here. And what I'm going to do is I'm going to go ahead and add a middleware in front of this, which is use response caching, like so. Okay, no problem. That puts the middleware in the pipeline. This has been available, like I said, for a few versions in ASP.NET Core. And then I'm going to grab this block of code down here so that I can actually configure this from inside my endpoint to configure what this caching is going to do. So I'm going to add this here. I'll uncomment that. And so what does this code do? Well, it grabs a feature out of the HTTP context, which is our response caching feature. In here, I can set a property that says I want you to vary the cache by query keys, which is very common, obviously, if I send a query string of some sort. In this case, I'm accepting size via the query string because I don't have it in my route, so it'll come through as a query string value. So I want to vary by that. And then I go ahead and say, let's set some caching here. I said public is true, and I want it to cache every 5 seconds. So if I rebuild that, and I come back over here and I hit refresh, now if I hit refresh every time, it's not working. And you go, well, that's unusual. Why is that not working? I just set up caching. If I hit this load thing down here, oh, it does start working. And this is where we start getting into the intricacies of caching in HTTP and on the web, and how the user agent behaves when it comes to caching and how the server might behave. So the response caching in an ASP.NET Core to date has been what you would term strict HTTP caching. So it uses the HTTP cache standards, the cache control header, to control on the way in and on the way out what the caching behavior will be. And so you probably know that when you hit refresh in a browser, the browser doesn't send the same request it did the time before. It slightly modifies it. It adds a header that says, oh, this is a refresh. I want you to not cache the response. And if you didn't know that, now you do. That's why hitting F5 in the browser is different to hitting a link that goes to the same URL as the current page, which is the difference between these two here. The browser, when you click the link, will go, oh, this is cached. I cached this previously. They didn't hit refresh. They just navigated. So I'm going to give you something that's satisfied from the cache. And if I open up F12 and we watch the network here, and I hit load, and I hit load again, what we'll see, if I can see these things, is over here on, you'll see it says these were fulfilled by disk cache and memory cache. The browser tools are telling me that these things weren't actually sent to the server. And then if I wait a little bit longer and then I do it again, we'll see that this time that's not the case because I only set it to cache every 5 seconds. And you might be saying, well, that's great, Damien. You explain how all that stuff works. That's not what I want. I don't want my cache to be invalidated because the user hit F5. That's not what I expect from application level caching. That's what we've fixed for you in ASP.NET Core 7. So there is now a new caching system that's available, which you can use right alongside the existing caching system, and it's called Output Cache. And for those who have been using ASP.NET for quite a long time, before we had ASP.NET Core, we had System Web, and that had a feature called Output Caching, which worked very similarly to what I'm about to show you here. So instead of using response caching, or next to it, I can say, let's use output caching this time. So now I have a middleware in my pipeline. I think this one requires services as well.
Yep.
So I'll say add.
Services.add.
It helps if I do that. Add output cache, okay, like so. So now I've got my output cache services and I've got my output cache. Now this system is more modern than the response caching that we have in ASP.NET Core. So rather than doing all of this where I had to manually set up a bunch of stuff per endpoint, I can use the endpoint and routing metadata system to control which endpoints get cached. And so to do that, at the end of this endpoint definition here, so remember this is my handler, and at the end of this I can call other methods to attach more behavior to this endpoint by way of metadata. So we have a new method here that will give me output cache. I can say cache output, and I can just pass it nothing. So if I do this time, and I go back, and I refresh this page, okay, so now no matter how many times I hit refresh, it's just giving me the same response. You can see that timestamp there is not changing. Now, just like any good caching system, you can configure this in all the same ways that you would expect. You can set up vary by for all the normal things like headers and user and query strings and all the rest of it. You can create a custom key if that's what you need to be able to do from custom pieces of metadata. And because it's based on metadata, like it is here, you can apply this to endpoints directly, or you can apply it by way of policies. So you can create basically a cache rule with a whole bunch of things, give that a name, like a cache policy of whatever you want to call it, cache this thing for 10 seconds, and then you can apply that to certain things by name. Very similar to how you can do so with authorization today, and how you can do with rate limiting like I showed you before. So that is output caching in ASP.NET Core 7. Awesome.
What's next? What do we have next? Counters and performance.
Well, that was like a smattering of applause.
Stop applause. Holy crap. It's a cool feature. Funny, it's Damien's feature that he asked for, I think, when we did...
I think I logged the issue for this.
2.1, like in like maybe 4 versions ago.
And then it took us 4 versions to build output caching, but we've finally done it. All right, so there are...
So we have like 15-ish
Yep.
minutes left. We should figure out which things we think you want to show the most.
Oh,
So there's a lot of stuff to show.
I can do problem details.
Problem details is probably a good
quickly.
one to show.
Yep. All right, and then we can maybe look at
Dig
some of
into
your
more stuff.
patterns. Sound good?
Yep.
All right, so problem details. Problem details is an RFC, I can't remember, it's got a 7 in it.
4720336.
About a standard schema for responding with JSON when an error occurs for an API. We added support for problem details in MVC back in ASP.NET Core 3, I want to say. That was a while ago. And for API controllers, it does that by default. If you have any type of validation error or any exception, it'll do that for you. And then there's kind of some primitives. There's a problem details type, but there's really no other part of the system that will return problem details for you. In ASP.NET Core 6, we introduced minimal APIs with this new sort of results dots, and you can return problem details from that, and that you just write the code to do so, and that works. But what about your exception handler? What about the developer exception page? What about other things that might return errors? Wouldn't it be great if you could just configure all of those to use problem details as well? Well, that's something that we've enabled in ASP.NET Core 6. Now, I do want to also mention that before that, there has been some popular middleware in the community for doing this before now, and they still work great. So some of you might be using those already. If you want to just put something in your pipeline and have everything get caught and then formatted as a problem details, you can still do that. That's not a problem at all. But we do now have new built-in support for this in ASP.NET Core, and it hooks up to a number of the primitives by default. So if I go ahead and add problem details here in my services, which I have, that's kind of all I have to do by default in order to get a few of the existing components to now work with problem details. The first one is status code pages. So if you haven't seen status code pages before, it's a middleware that sits in the pipeline, and then any endpoint, any response that's coming back that sets a status code without any body, typically, the status code pages can modify the response. So rather than being an empty body, it will format you a nice body for a status code 3.0 whatever or 4 or whatever it is that you want to be. So if I go ahead and run this application, here's my Swagger. I'm going to just zoom in back out a little bit. So here's my status endpoint. I'm going to say, hey, let's try this out. I'm going to just make up a status code that doesn't exist. We'll say execute 1, 2, 3, and that's running. It's taking an awful long time. That is not that one. We have so many things running now. That's not that one. Let's cancel that one and refresh that page. Let's try that again. Let's make sure hello world works. Okay, that works well. There's my hello world. Very, very good. Let me do the, I've got an endpoint here that will throw an exception if I execute it. Okay, so there we go. So I've got an endpoint that if you hit it, it throws an exception. If we have a look in here, we can see it's actually returning it's returning JSON. And this is the problem details service doing its work for you as a result of me adding the exception handler. So you've probably used the exception handler before. Let me go back to my application. This method right here. This form of using the exception handler has not been supported until ASP.NET Core 7, though. You typically have to pass arguments to say, well, what do you want to do when an exception takes place? Do you want to redirect? Rerun the pipeline, I should say, at this path. You want to run this code. Now you can give no arguments at all, and as long as you've added problem details, it'll actually just go, okay, well, you've got problem details configured. I'm just going to return problem details, assuming that the client supports JSON. If the client doesn't support JSON, it'll just format it in plain text. Okay, so you've got a very nice, very simple, safe. Only logs, safe stuff. It doesn't give you all the stack traces and stuff like the developer exception page does by default in the box now, which is kind of nice. I've also got an API controller down here, so if I scroll down, all the way down, I've got a greetings controller, the API controller that I talked about before, and I just want to show that this service that's new in 7 that you can customize will plug into all the places that understand problem details in ASP.NET Core. So if I go back to my application now, and we try and hit the greetings, I'll try that out, hit execute. Okay, so that's working, but if I hit it again, oh, this one, I logged an error. So I actually set up this endpoint so that if the current time ends in an odd second, it throws an exception because it makes it really easy to demo, right? I say, so if I just keep hitting execute here, sometimes it'll work, and then it throws, okay? Super nice. And so what it says down here is I've got my problem details, and you'll note that it actually puts the trace ID in there for me automatically, which is super, super nice. But what if I want to add my own fields to this problem details and have them show up everywhere where problem details is returned by my application? Well, you can customize the problem details. So I've got a method here, customize problem details, which I'm going to hook up now. So if I go back to where I add problem details, and I just pass it this customize problem details method group, I'll show you what that code does. It's pretty straightforward. It's like most stuff that you would see in ASP.NET Core. We'll just hide this one. I get a set of options, and then inside this I can set a delegate that will get called, and then the context that gets passed to me when a problem details is being formatted allows me to go ahead and do whatever it is that I want to do with it. In this case, I'm adding a property called node ID, and I'm just putting my machine name in there. Okay? So if I rebuild this now, and I go back to the application, and I run the exact same thing, and I'm doing this in the API controller, hit execute, you can see now that that node ID property is showing up in problem details. And the problem details spec supports extensions. There's a minimum amount of things that you're supposed to have in there, but then it's free. You're free to go off and add other things in there as well. And because it's all one format, it's all JSON, the client should be able to handle that without any problem. So that is problem details in ASP.NET Core 7. Under 5 minutes, I want to show one more demo before we go to questions.
You're going to show it?
The trimming. Like,
you're going to show the big one. Okay, the big one. Okay,
okay.
Good, good.
All right, so.
Damien has been coding all week on this thing, and he wanted to show it, okay?
Actually, it was in the description for the talk.
He's so proud. He's so proud of it.
Right.
I'm proud of you too.
So I'm assuming that there are people here who have heard and are watching online who have heard about .NET Native AOT. There's been a long sort of history of what would it mean, how cool would it be if I could take .NET and I could run it or compile it down to a native executable, something really, really small, okay? Smaller, faster, uses less memory. That's kind of the promise that we have. So if I'm just going to jump out here, and I'm going to go to another folder I have called trim to do. And for those who are interested in looking at this afterwards, this is up on my GitHub repo, github.com/DamienEdwards/trimmed to do, is where I'm investigating kind of this interesting area to do with .NET trimming and .NET AOT, .NET Native AOT, which are somewhat related. Native AOT uses trimming, okay?
It's a spectrum. So first you
trim. It's a spectrum. You trim.
And you go native.
Right. Well, it's actually a larger spectrum, right? Because you go normal publish, framework dependent, self-contained publish, bring the runtime with me.
Right.
Single file. Publish, huge executable, 100 megabytes, but now everything is in one exe. A trimmed single file, where we knock out everything that you don't use, and there's different levels of trimming that you can turn up or down because it can be complicated, right, to make sure that it doesn't break your app. Then there's ready to run, which is like an extra thing that will add native bits back to your app so that you don't have to JIT during startup.
It's improved start time,
but the file size gets
bigger.
Much bigger because there's native stuff. And then there's turn it to 11, which is AOT. Okay.
Which is the JIT, and you throw it in the garbage.
So just to finish here, I'm going to run a script which says Hello World console. I need you to believe me, this console app is just Hello World. It's all it does, okay? All I'm doing here is building the application and passing the right flags to it so that it gets built. And then I want you to cast your eye to this part of the output here that tells you how big the final application was, which in this case was under a megabyte. And so I was able to create a console application, a .NET console application that does nothing else but say hello world, granted. But the whole thing is a self-contained executable, native with no JIT, that is under a megabyte. I also have another one here that is a web app. So if I do hello world web, and I run that one, which I'm hoping will finish before we do, we can kind of see the difference. The repo has different grades. So it has like an empty web app, it has a stripped web app where I turn off a bunch of stuff, it has HTTP listener, and it has sort of a prototype Kestrel Direct. So this one is 17 meg, quite a lot larger, because ASP.NET Core has a lot of features. Right? All the great stuff that we show you, that's all in the box. Depending on what you got used, we then trim all of that out, but we have to do more work in the framework to make it more trim-friendly. So I encourage you to go and look at that if you're interested and have a look at how small we can make those applications. And I want to let you know that we are working on this every single release to make it smaller and more compatible with the apps that you're running today. With that, we have about a minute and a half, so